So page 41 is going to be the rational zeros test. On pages 39 and 40, you were learning about synthetic division. And when you were given your polynomials, you were also given factors or the zeros. But there are times that you're not given those. You're just given the polynomial and you're asked to find the roots or the zeros. So you need a test that will allow you to restrict the number of zeros you have, because technically there are infinitely many. But the rational zeros test actually narrows down what numbers you should test. So the rational zeros test says if a polynomial f of x has integer coefficients, every rational zero f has the form. It's going to be p over q, where p is the constant term and q is the leading coefficient. So in order to find these zeros, we're going to take the ratio of the factors for each combination possible of p over q, and I'll show what that means in just a second. Afterwards, we'll use synthetic division to see which are the correct zeros. If we end up with a remainder of 0 in our synthetic division, then we have found one of our zeros. And so we can check the others for your rational zeros test to see if there's any others. So for example, we have f of x equal to this third degree polynomial. P in this case is going to be -3, and q is going to be equal to 1. So instead of checking all of the possible numbers for zeros using synthetic division, things like 2, 3, 7, 1/2, 2/3, and so forth, we're just going to use the factors of -3 over 1, or p over q. And so when we look at the factors of -3, you've got 1 and -3, and -1 and +3. When you find the factors of +1, there are 1 and 1, and -1 and -1. So we'll take all the possible combinations of these. For example, 1 will be put over 1, 1 over 1 again, and then 1 over -1, and 1 over -1. When you do that, you're going to get +1 and -1. You'll do the same thing for -3. You'll put it over 1 and -1 to get +3 and -3, and you would continue to do it, but these two guys will give you the same exact answers. So instead of testing all of the possible numbers like 1/2, 2/3, 5, 7, and so forth, you only have to test 4 for your rational zeros. You would test 1, -1, 3, and -3 using synthetic division or long division and see which one gives you 0. Whichever one gives you 0 is going to be a root or an x-intercept, and so you can figure out which ones are going to be your rational zeros. This does not find irrational zeros, things like square root of 7, square root of 2, and so forth. So you would have to use something else to find those. Another example, example 2, we have now a 4th degree polynomial where p in this case is 8 and q is 2. So we'll take all of the factors of 8 and put them over the factors of 2 and then write down all the different combinations you would get by finding their ratios. So factors of 8 would include 1 and 8, -1 and -8, 2 and 4, -2 and -4. The factors of 2 would be 1 and 2, and then -1 and -2. So if I start making all the different possible ratios of this, I'll get 1 over 1, 1 over 2, 1 over -1, and 1 over -2, which would give you 1, 1/2, -1, and -1/2. You'll continue the same process for every single factor. So then you would put 8 over 1, 8 over 2, 8 over -1, 8 over -2. That would give you 8, 4, -8, and -4. If you continue this process all the way through for every single one, you'll end up with some that are repeats, and so you just have to list them once. So I would get 1, 1/2, -1, -1/2, 8, -8, 2, -2, 4, and -4. You can also rewrite this as ±1, ±2, and then so forth. So instead of testing all kinds of numbers to figure out which ones are zeros, like 3, 7, 10, and so forth, you only have to go through this list and see which ones give you a factor of 0 when you use long division. And that will help you find your x-intercepts. So the rational zeros test just helps you minimize the amount of numbers that you're going to test to find the zeros when you're using synthetic division or long division, and this is when they do not give you the zeros or your factors.